reviews.
Just give it up.
Nice, because we're gonna get that feedback form soon. So pepper it up with all those niceties.
All 5 stars.
5 stars.
No, but also make sure you're getting the most out of it. All right. Hopefully that is part of it too.
Here for the green.
All right. How are we looking for this number 1? Is anybody already there yet that they may have the answer? No. All right. Cool. Give it a little bit more. Online as well. You guys can type it in also for online if you got any background noise that you don't want to. But Michael, Savannah, if you guys want to type it in, you're good as well for that. All right, again, this is going to take us to the table that 22053 mentions, because you have 7 dryers, so you got to deal with the 7 and that process.
Is it 464 watts?
464?
Yeah, do you do 5,000 kilowatts times the 65% and then divide that by 7?
Yes, so that's the other way you can do it. You can do each individual one, find out what that already is with the demand factor, and then just multiply that by 7. That's fine too. But to the 460, no, that's not correct for the wattage.
But
The first number that I was just given was like 4 something. I got rid of it, but something like that.
what did you get from it?
All right, so for this one, remember, if we head over to the whoops, 53. Sorry about that. I meant to put 54. My complete and total mistake, and that might be possibly why I got an odd number up front. So I apologize. It is not. I was just going in order. My brain, sorry about that. Just went in order to the first one. It is the second one. It is the dryer one.
Whoa.
2000. Michael's got. Hold on. Let me type in what we got online on hold 64 VA. So let's hold on that one. That one sounds possible. So it's the electric dryer one I meant to say. I apologize. I mean, sorry, I said the electric dryer, I said the wrong article. But here's the table that I want to mention, 22054, also on this page on the top right. So here is where we deal with finding the demand factor for 7 dryers. So I'm going to pause there and let everyone... Michael, that one seems a little small to me as far as the number goes. It might be for 1, and if that's the for 1, then multiply that by 7. But I don't know if that's the one of them. It might be. It sounds... Yeah, okay. No worries. You're good. Now you're all. I'm hearing it. I'm hearing whispers of the correct number out there. So
250.
Yeah, this is why. What was it again?
3,250.
3,250. All right. Now we're in the numbers where it's starting to seem like it. Yeah. That's why I said 2,000 was way small. So, but I don't know. We'll let everything kind of work itself out.
3,000, not 30,000.
Oh, if it's 3,000, we're still low.
Per dryer, though.
Oh, you're saying per dryer?
That's what I got, per dryer.
Right. But notice what the question is saying. What is the total VA for 7 dryers?
Yeah.
So when I'm hearing these 3,000, this is what I'm saying. That is the wrong number. It is the right number maybe for 1 dryer, but it's not the right number for the question.
1,600, right? We all agree.
All right, is
it 21,000? Is it 21,000?
Now, 21,000 again. Now we're starting to get into some numbers that could be possible. What was the rest of that?
480.
It's 22,700.
No.
We'll put them all. It doesn't matter. We'll just see which one's right. 22,000?
Yeah, 750.
750. All right. Challenging.
What's wrong?
2 of them challenging. So, all right. Now let's do the math for this.
Real answer is
Let's say it's 22.
If you look at the question, the first thing of note is 48,000.
Better.
21.
4,800.
But you said you use 5,000 if it's anything less than.
Correct. That's the first thing we're looking at there. So if we go to the article again, it mentions minimum has to be 5,000. So there's the number we start with. So I just want to make sure whoever did math started with the right number. So your first number on your equation should be 5,000. Now, either one that you want to do, if you want to multiply that by I'm just going to do times 7. And then from here, we multiply it by the demand factor for 7, which was what, 65? Yeah.
Yeah.
So now let's see what this comes down to. We have two numbers, see which one's the right one. Whoever gets it right gets extra homework. Oh.
Gets extra homework.
That one. Wow. Turns out you have extra homework.
Yeah.
No, well done. So it's 22,000, but you guys see how we got there. 22,750. So now again, we're going to be answering this, and you will have to turn this in at the end of us wrapping up both assignments. So make sure that you can number paper 1 through 5, and then you'll see for the other one. You can turn it all in one paper, even though there's two separate ones. Or you can print them also.
Oh, you?
22,750 then.
Yeah, that's the correct answer. Yep.
Oh!
Yeah, sorry about that.
I get it.
One day.
I understand it.
Now, again, if you do 4,800 multiplied by 7 and then do the process from there, you will find this answer. Because I know that this is one way we can do it, and so this will be an answer as well. So when you look at the multiple choice and you did your multiplying and you saw the 21,000, we can pick that just because it looks like the right answer. All right, so for sure, at least 4,800 and 5,000 are going to be both options as a multiple choice. So just be careful with that starting point. A lot of these are going to be that. Be careful with the starting point, and then you can get to the right answer at the end. All right, I am recording this, so you'll have that as we processed it if you want to watch it later in slow motion.
For the computers, do you always use 5,000?
No. So, great question. Do we always use 5,000? No, we do not always use 5,000. For example, if this would have been 6.2 kW, now we're over 5,000. So we use this one now. Yeah, and then we would use this one times 7.
Oh.
Use 5,000.
I understand the formula now.
Or the listed number, whichever one's bigger.
Very
So
good.
a number that's less than 5,000, use 5,000. It's a number that's more than 5,000, use that number.
Within the kilowatts, that is, right?
Yes, for the kilowatts.
Okay.
Right. So if we
1,000%.
Oh, sorry about that. Have I been on the wrong? There you go. Sorry about that. I think I've been on the wrong screen.
Yeah.
Yeah.
Yeah, you did.
Yeah. There we are.
Okay.
So yeah, that's where the 5,000. Now it'd be back on that same screen. 5,000 is or larger. Yeah, whichever is larger. And we have that also, just to remind us, for the EV system as well, which is right next door, a neighbor, and we should just mention it. We have the same or whichever is larger. All right, so the EV are two of them, and I was trying to explain that yesterday, which is due to the fact that for both these now, the dryer or an EV system, it's just not likely that as a new home, you're going to get those. Those are things the homeowner brings, so we just make estimates. Now, if we happen to have the information, there's where the whichever is larger comes in. All right, now on to the next question. All right, the next question says, again, what is the total VA for 12 ranges at 7 kW nameplate rating for each? So again, like the last one, I will prompt us to the article. This time, the correct one, 55, and that's the one that really all this does is takes us to the actual table, which is all we need for any question related to ranges or any kind of household cooking equipment. If it's kitchen equipment other than households, like I said, Article 220.56, the next one, goes into the kitchens. Or restaurant kitchens, I should say. Alright, okay, I'll give a little bit of time and then I'll work out the problems with us. And as we're getting the answers again for online, if you guys have it, you can type it in.
I think you made a per table 220, no?
Whoops. Once again, wrong article. 220.55. All right, so now we'll start to get into the question. All right, now with this one, there's no minimum. And again, the approach is houses come with the oven or the range setup. So we just treat it, no issues with the kilowatts, whatever it's telling us. And then we're going to multiply by the correction factor for 12. So make sure we got the right starting point. Oh, with these, it's just, where did I start? Could lead me in the wrong direction. All right, so what do we think? Anybody got an answer for me?
26,880.
That's what I was gonna say.
Me too.
Say that again then?
880.
26,880.
880. All right, good. All right, now it's a different person, so I'll trust. No, but we'll do it together. All right, we got 12 of them. So again, I like to just multiply it straightforward and deal with that number. So if you did it individually, this works out as well for you. But if you did it this way, it would have been a whopping 84,000. So again, just to help understand what's going on with that 84,000 watts that these ranges are going to be producing when they're on, and that is that we don't have to worry about all 12 of them for the main breaker. All right, the main breaker only has to worry about a percentage of that, which for 12, and here again, the right column is everything. Got to make sure you're on column B. There you'll find the times 32 situation. And then, very good. It checks out that your number is correct. All right, there's our answer to question number 2.
Do we use the same table for the next one?
For the next one?
For number 3, yeah.
No.
Dude,
You don't remember that one? All right, we'll erase in case anybody needs it. Let me know. But if we're all good and no questions on number 2, we'll move over to number 3. This one's there. These are my fixed in place appliances. This is coming out of Article 220.53, the first one I gave, that has our fixed in place appliances. So again, remember it has to meet two. Has to meet both of them.
because there's only 3, add them up, right?
Ah, no, yes, you're good. I don't want to be so mysterious, but yeah. Correct, that's what the article is telling us. Again, both of those. One, they have to be more than 500 watts each, and we got to have 4 or more of them. But now what? Hopefully everybody remembers what to do with that. That's the fact. Now what do we do with that fact?
That's at 100%, no?
Correct. Alright, at 100%. So what we do with that fact is nothing. We add all of these up and call that a day.
What's the total in place funds?
40,800.
16.
Fixed in place plans.
Does that look about right for everybody?
Is that 1,000 or 1,600?
1,600.
1600. This one is 1600. Sorry, yeah. Let me know if you can't see something. 1600. And we got 3800 water heater, and then we got the range hood. Remember, that's a little fan above the range. The extractor fan, sometimes called. So yeah, so if we don't have 3 or 4 or more, so that's first things first. We didn't even meet the 4 or more, so 75% is out of the equation. If we would have had 4 or more, then we got to make sure that they're over 500. But we didn't have that in this one, so answer to number 3 is, there we go.
38.
Oh, I'll bring it back. Sorry about that. Yeah, 3800 was the water heater.
Okay.
1600 was the dishwasher, and then the range hood 800.
Well, dishwasher's 16. We're just adding?
You don't
That's
take
it.
into the number of appliances or the kilowatt rate to.
4 or more.
Oh, why does it say 1, 2, 3, 4 for number of appliances?
This is for ranges and other.
So it's only 53.
There's a range.
Range
Oh,
hood.
right.
Oh yeah, range hood. Range hood is a
We're talking about.
fixed in place appliance. It's the little fan that's above the oven or the range, the stovetop, to get rid of the smoke. So that's also a fixed in place appliance. It's got a motor in it, but I just gave us the VAs for it. All right, remember that also is for quarter horsepower or more as well. So sometimes you get the horse, like if you're putting a sprinkler pump in, you're gonna get the horsepower on the pump. If it's a garage, same thing. And I think with garbage disposals and these things will get the wattage. I don't know if necessarily are gonna give us the horsepower to it. And so the question was, do we just add them up? Yes, that's it. If we're looking for, the question says, what is the total of all 3 of these, then that's it, we add them up. However, again, let's now do an example with this one to make sure we understand what I mean. Let's say we do have a 4th one, right? A garbage disposal. And this one is whatever they are, 1100 VA. So now we have 4 of them, and all of them are over 500 VA. So now we meet both of the requirements. So we would now, well, we have the original number, add this disposal, right, to that original number, just so we have a total, so I can show. And then we would multiply that by 75%. Now the 75% is allowed. So you can't apply the 75% unless you meet both of those requirements. Right, 4 or more and 500 VA each. Minimums. But we don't have that in this one. We'll do more examples when we review for the exam and everything. So I just want to see, yesterday we did an example with 4 of them. So today here's an example of only 3 of them. You might find both in the exam. You got to know what to do with both of those situations. All right, the question is already in front of you, so you can tackle it. Question 4, if anyone has that answer already, hold on a second. Let's give everybody a chance to try to answer this one. See if you remember from the notes yesterday what you have to do here first, and then figure out what's next. And as I mentioned yesterday, it's going to be a very realistic thing for all of you, since electric vehicles just becoming more and more the norm, and you will, I know very few people in this town, and already one of them contracted me to put in an EV charger, so It's happening to everybody.
If they're conditioned smaller, multiply.
It mentions here specifically that.
That's what it says in 226. Seven, 220. Shall be made if motor or if flows apart from the load on lower speeds.
Oh, yeah.
Now for this one, I will help prompt at least what we're supposed to start with, which is Ohm's law. Your initial step here
Yes.
is Ohm's law. That's why I didn't even want to put the article here yet. It is 57. There's the article that we'll go to. But first, we need to know which one is larger. Because we're getting information about the EV charger, meaning we don't just have to settle with what the code is telling us. The code says the EV load shall be calculated at either 7,200 watts or the nameplate of the equipment. And as I was mentioning yesterday with the EV chargers, since you have such a wide range that you can connect these to, you're going to be choosing that on site. You need to know what to do with that and how to approach it. So one, you need to be able to size the wires correctly. It's pretty easy as far as the steps go, but two, just to make sure we're code compliant. So we were going to do Ohm's law first. Right, that's the first thing we got to do. Let's come up with this wattage. Now, 240 volts times 40 is 9,600 VA. And now we can verify with the article. The article says minimum of 7,200, but if you got a bigger one, as we were saying earlier with the dryer, if you got a bigger one, use the bigger one.
There is no 220.
It's very small.
The article, yeah, it is tiny, and it's right above the last article on the right. So it's right above 60. Right down, page 96. Yeah, right down there, bottom right-hand side of 96. Electric vehicle supply equipment. So if you don't have this note highlighted, or both the dryer that's right next door neighbors to it, make sure we got some. And this is new. I don't know when a lot of these codes changed around, but when I had my 1993 code book.
1993?
Yeah, that's the code book I started with.
Wow.
Yeah. Well, come on, don't say it like that.
Get this man a nursing
How
home.
old are you?
Yeah.
So I turned 30 in May.
Oh, you're good.
You're
Yeah. Well, I mean,
Cold?
Yes.
Also swimming.
3 years before.
if it sounds better, we got the 96 as like a year after I started. Because I started in 95, so we were still on the 93 code book, and then 96 was the new code book, so we adopted it midway. So I started my apprenticeship the first year with the 93, and then the next year I changed to the 96.
Man.
Say that.
All we do to be
We pop up message snap.
NW every night. Wu-Tang.
All right.
Those rappers.
All right, any questions on these? I'm going to head over to the last question that we have for this assignment, but if you guys got any.
Yes.
All right, good.
I'm lying.
Now, we are going to put all this together, so remember all of the things we said here. This is why we did this one first, because now we'll take this into a live scenario of a whole house, and we got to remember all of those little rules that we had. I separated everything by the thing that they are, but last question before we head to that one, because we will face the air conditioner over there. is question 5. Total VA for an HVAC system. Now, this one is not titled HVAC on the code section. This one is coming from the non-coincidental load section. All right, and as I mentioned yesterday, in the first sentence gives us kind of a breakdown of what's going on, is non-coincidental loads are two loads being fed by the same breaker, or OCPD fuse if it's fuses. But both of the loads are not going to be on at the same time. That's why the first sentence says that. If it is unlikely, and this is the one I wanted to talk just a little bit more about today, since I kind of rushed through the article yesterday a little bit, because it's wrapping up at the end. But if it is unlikely that two or more non-coincidental loads will be in use simultaneously, using only the largest load that will be that will be used at the one time. So if it's a heater and an air conditioner HVAC system total together, then like it says, it's just common sense. Use the bigger one of the two, so when the smaller one is on, we're covered, and when the bigger one is gone, that's the one we're concerned with, we're covered as well. All right, that will be used on the same time. The load or the total load of the heaters are okay permitted. All right, so that's the first thing. Use the bigger one of the two. But it goes on to say, if a motor, which again, you could have a non-coincidental load that is two motors, like an example would be, a piece of machinery that has two motors, one that drives the machine in one direction and one that takes the machine in the other direction, moves two things at the same, but you wouldn't have those two going off at the same time, like an elevator wouldn't be going up and down at the same time. So that's why it mentions motors. But the most common non-coincidental load that we're going to look at is air conditioning systems. So that's why it says if a non-coincidental load is an air conditioning load, right? It's part of the non-coincidental load. Then if this one is not the largest of the two, right? If the air conditioning is the bigger one, then like the beginning said, pick the bigger one of the two. But if the air conditioner is not the bigger one of the two, then first we run the percentage increase. All right, the last sentence is, if we didn't highlight it yesterday, just make sure you highlight it. All right, just highlight 220, 60 non-coincidental loads and that last sentence, which kind of sums it all up. 125% of either the motor load or air conditioning load, whichever is larger, shall be used in the calculation. So here we have an HVAC system, and now hopefully after that, you can tackle this question.
It's 45, it's 45, so.
We just
Yeah,
add
that's why.
So yeah, 97.
Which will be 56.
Yeah,
It's a manager system, 56.
5625. We'll hold it right there. Savannah's got 5625.
Did you see that question?
All right, possible answer.
Good hair answer.
I see.
Right, so what would we do here, right? We have an HVAC system. It has an air conditioner, 4,500 VA, and it has a heating unit inside, 5,200 VA.
Those are faces.
So the heater's bigger, HVAC smaller, but we increase the HVAC by 1.25 first. And so I'll put that math over here, 4500 times.
Oh.
And here's where correct answer, correct number. So this is the load that we will size. We'll use to size for our main breaker. By the way, it's the same approach when you're sizing just the breaker that's going to protect the HVAC, but that's just coincidental.
Use the smaller number instead of the big number.
What's that?
Why do we use the small number instead of the big number?
No. The correct answer is the bigger number.
Oh.
Yeah. This one now becomes smaller.
Initially, when multiplying.
Yeah, why did you pick the 400?
Oh, yeah.
Okay. All right. So good. All right. So why do we pick that one? Well, the code section says if the heater is the bigger one, then we have to first increase the air conditioning load by 125% and see where that lands now. It could still be smaller. And then if it's still smaller, then we still go with the heater. All right, like let's say, for example, that this was, whatever, I'm going to use a low enough number that I know the math will work out, 2500 VA. So again, the air conditioning is smaller. So we first bump up the air conditioner by 1.25, see where that increases us to. And let me get us that number here for the example. And now it only takes us to 3,125 VA. So we've increased it, but we're still smaller than the heater. So we would still go with the heater. It's always going to be the bigger load of the two. But the air conditioner just has to be ran through 125%. And again, this is a bit of a confusing code.
That's it, that's it, they're gonna be on the same breaker?
They're always on. This is what we're saying. We're saying that this system is a non-coincidental load. That means HVAC systems are both on the same breaker. The heater inside the unit and the air conditioner inside the one unit. It's like one unit, it's outside the house. Inside it'll have the heating system, and inside it'll have the cooling system.
So the air conditioning is also going to come first for the VA times the 1.25?
Depends which is bigger.
If it becomes larger, then yes. Right, so here we have the cooling system is 4,500 VA, and then the heating system is 5,200 VA.
So let's say someone did,
So 150 to
someone went with the lower number, that's when you're gonna start seeing your breaker trip, cause.
Exactly. So if you went with the lower number, and then the heater kicks on, now you're dealing with more amperage, and your breakers could trip.
Is that cause you didn't calculate your demand factor correct?
That's because you didn't increase your load. Yes, it is still a demand factor, but it's an increased demand factor, not a reducing one. Right? This one actually increases the number. So you should have done this first with the air conditioner. If now the air conditioner becomes the bigger one of the two, then we still go with the bigger one of the two. Always at the end, the bigger one of the two. And so how these kind of get, just because I actually ran into it, and I think I mentioned it, kind of slowed me down for a second. I was like, wait a minute, do I got to provide two breakers for this one thing? But then I was like, no, wait a minute, it's a single unit. And so that's what happens. But when you look at the nameplate information on the back of an air conditioner, it'll tell you the heat, it'll give you the cooling information, right? The PSIs and all that, all the heating elements and all that stuff. So it has both information. And so, for example, you'll see something like 30 amps here, and you'll see 30 amps here. What we are not going to do is go, all right, I must need a 60 amp breaker. Because I have a heater that's 30 amps and a cooler, or the cooling system is 30 amps. But instead, what we all need is just a 30 amp breaker. That's all we need, because the heat and the cooling is not going to be on at the same time.
That's true. Well,
Never. The system is designed that way, to not run both at the same time.
it does.
So it'll always be this way.
Killing temperature.
Alright, so again, this goes for the branch circuit breaker that you're gonna wire up the air conditioner to, and then the main breaker as well.
Well, how does it work when you have like different rooms with different temperature controls? They're completely separate units? Like
Yeah,
HVAC?
so I mean, it takes us a little bit more into HVAC systems, but actually we do work a little bit with that system in commercial buildings. It's done through the vents, right? It opens and closes damper systems. Now, depends on what we're talking about. A house, you're not able to do that. A house has one unit outside. It's the whole thing there with, you know, someone being cold inside the house. Well, too bad. Because you have one unit that pumps air in here. We cannot regulate this one. But in a commercial building, it's a little bit different. A commercial building, first of all, you have multiple air conditioning units. You have multiple ones. So you have a bunch of rooftop air conditioners. And what these are doing is they're pumping air, of course, into the air conditioning system. And then they'll have drops into different offices. or rooms or whatever. So same thing here. I can't change the temperature for each room with the air conditioner, just like with the house. All right, remove these, you still have the same thing that I had in the house. But what they do in buildings like this is they have damper systems, but vent systems if you want, and you can regulate these.
Oh, the silver things?
Yeah, so I can make it so that only 20% air is coming through this. And so I reduce the air coming into the offices over here. And then same thing, let's say for example, you have the vents here too in the offices as well. So you can open and close the individual office vent, which is not going to change so what they do in commercial buildings is they just leave one temperature on the air conditioner, like say 60 degrees, that's it. And then the best they can do is try to regulate how much pressure of air goes into the room. That's why you always have people complaining in commercial buildings about the air. So they do their best to regulate it, but you know, you're just controlling airflow versus temperature, or the on and off of the unit. All right, let's move on. So if any other questions come up, let me know. But we are going to get into now putting all of this together. So remember, this is one assignment. You can put all these on one page, answered 1 through 5. And then for the next one, all right, the next assignment is we're going to tie all of this in together. All right, now the whole house is going to come into effect. So that means that two things is what it means. It means one is not every house is the same. So first we have to figure out what's in this house versus another house. And then two is remember all of the little things that we had to do throughout each one of those appliance questions. And we'll have to do them here as well if we have that appliance. Like for example, and what I mean by each house is different. There's no EV system here. So we don't have to worry about the EV system. It's just not in this. This one doesn't have a garage. This one doesn't have a pool. It could have a pool. It can have a dozen things. So each house is different. But this is how we'll approach this house. So at the end, this is question 1 and this is question 2. Find the total dwelling load. All right, when I mean load, I mean VAs. And then tell me what the total amps is going to be. All right, and this will take us into the last part of understanding Article 220, which is conductor size. All right, we'll get there eventually. Breaker size for this panel, conductor size for this panel, and we'll even look at, well, I guess we can look at the grounding system as well. You're going to do all that next module. All right, this one will take a while. So what I'm going to do is treat these as sections. All right, section 1 like that. This is section 2. The dryer is its own section. The range is its own section. And then the heating HVAC system is its own section.
Let's keep it to ourselves.
So what I'm going to do is, first keep it to yourself as you're doing them. Also, I'm going to treat them as that. I'm going to slowly go and answer or put the answer for question 1. Make sure you got that. Because remember, this is if I start wrong in the beginning, I'm going to end up with the wrong answer at the end situation. So that you don't get too far ahead, I'll answer each section as we're going along. So take your time. Part 1, general lighting load, small appliance, and laundry circuit. Notice what the question is asking. Those are all on page 96 as well, by the way. So I will slowly start to build. Uh-oh, did we already start off wrong?
Yep.
Yeah.
Then pause, come on back. All right, here's our starting number.
Oh, man.
Get around, baby.
All right, so I'm glad I caught now. Before we're too far ahead. Yeah, don't forget our general lighting load. And I paused here because you still have more. You still have 3 small appliance loads and 1 laundry circuit. All right, just again, reminder of where these articles are. Same page, 22052. We got both of them. Walk through that article. Make sure you're doing everything correctly. I think they are done chainsawing. That's nice. Alright, well now I'll continue since there was... Alright, so we have 3 small appliances and each one...
Let's go.
Each one, exactly. So we have... And then for a laundry circuit we only have 1. Multiplied by 1500. So that is no change to that one. And here's our total. And now from here, this is our starting point. Again, we're only halfway through, sort of. What's that, 11? From here, you'll have to finish that up. Alright, good so far, but we can reduce this. Set aside. Remaining. Is that 8? Yeah. Multiplied by. So this is just section 1.
That's 95%. How far did it?
He's a wizard.
And now joins the original 3,000.
Use the first 3,000, and after that, whatever's left, that's why there's 2,000 left. And then you add.
And I will now circle it. This is our correct answer for section 1. Now remember, we're not. These aren't the. You don't have to turn these in. What you're going to turn in at the end is 1 and 2. But to get to 1, you got to do all of this. So we got to treat these by sections. So here's how we got to the first section, or through the first section.
Yes.
All right, questions. Here's our total. 3,000, final, and then end point.
What is it?
Is there any number that you're looking at on the board that you don't know why it's there?
You do 100%. And then the rest of it, so you subtract 3,000 from 11.
Yeah. The first 2,000 is
3,000 stuff.
After that,
By the rest of it.
that's what it's right. That's what it's 2 columns.
Where does it say that?
Yeah, remember, we don't subtract it, although if that's how you're understanding it, fine. We're setting it aside. It does have to be part of the final completed answer.
And the rest, and multiply that 8,400 by 0.35.
Exactly.
Get that number, 240, add it back to the original 2,000.
Why not? 225.
Is it over 20,000?
So what started off as 11,400 VA ends up at 5,940 VA for our panel. And so that becomes, and remember, these are not we'll get to our total, but this is for the first section, the number we're running with. And this, now you can complete section 2, 3, 4, continue on through. Each section has to be, bless you, done correctly. Alright, so I'm gonna leave that there if anybody's still writing it out. Well, if you're all done with this section 1, you can start to move on to section 2. And if you're catching on, steamroll ahead and get all the way to the dwelling load or total dwelling load in VAs. Come up with, like I said, question 1 and question 2.
Yeah, for the first.
All right, now once I see everybody done writing, then I'll erase this. I think we're good. Remember, this is recorded, so if you want to come back to any of this.
Yes.
Yeah. There's no complaints.
Yeah.
Why are you adding the 3 small clients and the laundry branch circuit to the lighting circuit?
Why are we doing the process this way?
Yeah, why add them all together?
So in the small appliance article and the laundry load article, this note here, starting at these, and this note here, starting at this load, allows us to do that. These loads shall be permitted to be included with the general lighting load and subjected to the demand factor on that table. Table 22045 is the table that gives us the 35%.
Maybe you should bring this up.
No, but at the very least, just highlight that. Make sure we have it highlighted, though.
Yeah, one.
They're both the same.
I guess that's true. We do that.
Now, the one thing I did want to point out is, and we caught it, hopefully, if this says 3, then we approach it with 3. If it says 2, then it's 2. If it's 10, 10, however many small appliance loads, the only thing is that the minimum has to be 2. From there, you can have as many as you want. 5940. I just wanted to move it over a little because we are going to add all of these up at the end, so I want to have them kind of in line so we can do that. All right, part 2 or section 2, however you want to call that, and we'll put VAs just to remind ourselves of what it is.
Yes. Yes.
All right, so section 2, right? These are our fixed in place appliances. This is our Article 22053, appliance load, dwelling unit, and this is the one that allows the 75% if those 2 things are met. 4 or more appliances, and both of them at 500, or all of them rather, at 500 watts or more. So I've given you some scenarios. Here's another scenario in how 4 or these fixed in place appliances can come at us, where we meet one, but we don't meet the other one. So don't just start running through it in the exam or, whatever, final, whatever. Where you get 4 of them and you see 4 and you just go, all right, add up the 4, 75%. Because we have one that doesn't, very good. The range hood does not allow us. Yep. All right. I was going to ask, which one doesn't allow us to use that 75%? Yeah, very good. The range hood is the one that ruins it all. So, what do we do next? That's the fact. What do we do now?
Just add them all up.
Exactly. Very good. Add them all up. That's it.
Mister,
Yes.
for that section number 2, at what number do we consider the demand factor above 10 kVA?
No, for this section 2, you have to have 4 or more, which we do. We have 4 of them, and they have to be 500 VA or more. So if we look at this, we have, okay, we got 4, 1, 2, 3, 4, but if we look at the 4th one, it's not 500 VA. So now we can't use the 75% here. If that range hood would have been more, or 500 VA, if it would have been 500 VA, we would have been good. But it's more than 500 VA, so. Sorry, it's less than 500 VA, so we can't use it. So therefore, no 75, straightforward, add them all up, and that's that for this section.
It's okay, no one's stupid.
All right, so 3 ways you can see, right? Look at the way I wrote the last question, like this. Here, we only had a dishwasher, a water heater, and a range hood. So 75% out the window. Here, we had 4 of them, 75% maybe, but then again, one of them is less than 500, so no dice. All right, hopefully that made sense. What do we have as total? Is 4,000 or 3,000?
4,800.
800, thank you, VA. All right. All right, let's see if we can do the next ones.
Did you pick the biggest number?
Yeah, 4,850.
800. 850, all right, thank you, and Savannah as well, wrote it there as well, 50, thank you. All right, good to go. Thanks, guys. So there's our answer. That would be the final answer for this one.
And you would have multiplied by 75?
Yeah,
The reason you don't do that situation, because there has to be 4 reserves, but they all have to be above 500 watts. But you got ones at 400.
yeah.
So then you don't use that one. You don't use it.
So if it is 500, we need.
I got it.
Okay.
I think so. Saying close that on a line, one bag, go to the laundromat.
All right, any more questions on the fixed in place appliances? Those two, those are the only two. Those are the only two that have all of these, add this up, multiply by this, and so on and so on. Where, we could go one way or we could go the other way. So, I'd say this one is just because it has this little element of the 2 factor. I have to have 4 or more of them, and then all 4 have to be 500 VA or more. All right, now for the clothing dryer, what number are we using?
5,200.
Yep, that's it. Nothing to it. Good to go. It's a bigger than 5,000 dryer. We'll use that one. Now, what about the range?
Multiply it by 0.8.
Well done. Doesn't even matter what number we're looking at. Don't even worry about a column. If you only got one range, it's the same number for both columns.
I do do it.
You know why you use one?
No, it doesn't. I mean, if you went to it, it's okay. Don't ever do that again.
But I mean, since it's
Yeah, 0.80% again. Just to remind us, it's a fraction. Sorry, a decimal, but it was upper.
You.
All right.
Big guy. Shut up.
Wasn't the 5 weeks for that.
All right, we're looking good so far. 4,800. And now to the last one. In a situation like this, where the house has nothing but a heat pump, same thing for the we don't have to do anything with this heat pump except count it at 100%. It doesn't have a challenging other, so it's not a non-coincidental load, it's just a heater now.
What section 3 would we find that?
Same section, non-coincidental loads.
But because they're,
There is no.
Well, in this question, I just set it up as though the heater is the one that we're going with. There is a wall, like space heaters section, but that one's different than what this a heat pump would be.
is
Heat
that
pumps
like,
are, well, go ahead. Sorry about that.
is that referring to like radiators or to like wall?
No, you may not have seen a heat pump, but if you can, so you can heat up water and have a heat pump that heats up the water system, and then it works as, I'm not sure if you've heard of a thing called a chiller unit. Chiller units. Chiller units is how they pump air conditioning into, usually where I've seen it, and that's only because I've worked in a lot of southern states, they use these to pump cold air and hot air into the building, using pumps and all of that stuff. So some homes in like the northeast sections of America, it's the only other place I've seen it, where a house could have like a chiller pump system where they're using the water that the city pumps into the house to heat up that water, and then the heating up of the water is how the heat is distributed. On the side of how to do that, I don't know how they distribute it from, but it works like radiators, sort of like that. Yeah, like radiators pumping water, it's heating it up, but a radiator is doing it with gas versus an actual heat pump that's doing it. And that's as best as I understand the heat pump system. I know to wire them up, but. All right, so for this house, we're done. If another house had more things, then we would approach each one. If we had an EV system, if we had, like I said, houses have pools, houses have garages, sometimes 2 garages. Houses potentially can have a lot of things, or they can be small and have only a few things. We treat each house individually. And so we wrap this up from here. And all we have to do from this point is add them up. And this is why I stress, each one of these sections goes wrong and we come up with the wrong total number here at the end. All right, so the answer to question 1, total VA, would be, has anybody got that number so I don't have to do it?
26,290.
26,000?
290.
Yeah, 290.
290. Thank you, sir. That's about right. Good to go. 26,290. So now you've learned how to calculate the total load to a house and come up with a total wattage demand that the house is going to require. And then now from here we start to size the panel and the wires. Now remember the number I gave us way back, and if you didn't have this highlighted, just a reminder from the 220.5 article that gave us a bunch of voltages that we use in these calculations. We are only going to go with 1 from the house, which is, this is the system we're using, the 120/240. Ultimately that's what our panel is going to provide, but just the 240 number for this calculation. That's why I just had you guys highlight that single 240. Just to not confuse it with the 120. So we're gonna, Ohm's law again, just to move that out of the way. Divide by 240 now to come up with the amperage below. Now if you do this, and if I'm not mistaken, this should be 110, right?
Yes.
All right, good. Now I'm gonna erase this. Again, it's in the video if you ever need to go back to any of that. That'll be posted today along with the other ones from this week. Now, last couple of steps, and for this I'll use and remind you that you have access to the standard guide method. So far, we've done up to 11. That's what 10 and 11 are. They were these 2 questions that you just saw here. So first, to wrap this up, these are the last 2 questions along with the appliance assignment questions that you'll turn in for a grade to the assignment that I posted today which is right below that one, assignment 2, standard load calculation. All right, you can start to turn these in now. I have them here if you need to go back to see any of the questions. And again, the video will be posted today so that you'll have how we did all of that.
Will you submit both of them today?
What's that?
You submit both for the?
Not today. You don't have to submit them today. They're not due till next week, but you can put these all on one paper and then submit them whenever you want, just as long as you get them in by the due date.
Okay.
Is it
So,
okay?
yeah, if you wanna-
Submitted?
What's that?
I submitted it as 2 images. Is that
Oh,
right?
it's 2 images, fine too. Yeah, I'm just giving you the option for 1 too.
Some people are really.
No, I know, but I am not. All right, and then, again, the last ones here, I gave as much information as I could on every one of these steps. That if you had and you'll have these questions like you saw individually. We have our what to do with the fixed in place appliances, how to treat the clothes dryer, how to treat the cooking equipment, etc., etc. And so we wrap these up. We figured out our VA total, and we've come up with our total amperage. All right. So now we have 2 things to do. We need to go find the breaker for this panel. Now you can go to Home Depot and purchase. And then we got to find the wire, but you'll notice this is sending us not to 31016, which is 99.999999% of the time the article that we'll go to select wires, except in the only ever case, of dwelling units, we go to a different article to find the wire. Let's do the breaker first because we need the breaker to get to the wire, and you'll see when we get to that article. So for the breaker, whenever you're looking for a breaker, remember 240.6. Unless you know the table. All right, if you have an awareness of some of the breakers on the table, then you don't have to go to Article 220 or 240.6. But if you are dealing with a multiple choice and you don't know the breakers yet, then definitely go to that article, which I'm running over to now since anyways. All right, now if we come to this table, fuses and breakers table. Again, this should definitely be a table you have tabbed out already on your code book. You should be able to get to this table quickly, know where it's at. This is 100% of the time where we come to size fuses and breakers. No other place, in fact, for those things. All right, largest fuse and breaker 6,000, smallest 10. Actually, a little smaller if you look up here. We have the 1s, the 3s, and the 6s.
So you can't go over 80%, right? The breaker.
Right. In this case, we are simply sizing the breaker to whatever number we landed at. So let me address that question for a second. We like to not load a breaker more than 80%. But that's for our branch circuits. Our branch circuit loads, we try to do that too. For breakers like our 20 amp breakers, 30 amp breakers, 50s, and so on.
A main breaker, you can just load it straight up to its whatever the
Yes, but why? Why can we do that? The reason why we can do that is because we've already done a bunch of calculating and reducing wattages when needed and etc. to be able to just pick this breaker. Right? We don't have to do anything else to the load on a dwelling unit.
What if there's like a surge or I guess
There won't be so the main breaker, remember, is protecting everybody. So if there's a surge on one branch circuit, that branch circuit's going to surge and it's going to pop the breaker that's on that branch circuit. But that load, even if all of your loads, let's say every single load in the house surges in one crazy Stranger Things moment, everything just goes haywire. All of the individual breakers will pop. The main breaker will never see that problem. The job of the main breaker is just to make sure that as things get turned on, right, as long as everything is turned on, the wires that are coming to this main breaker that are handling all of the amperage, coming from this house, it's all that amperage here, those wires are protected and if anything overloads in this side, then this breaker will trip. All right, but this breaker is never, ever dealing with an overload unless, how does a breaker deal with an overload? In the future. In the future, if this person buys an EV system, if this person buys a jacuzzi, if this person, whatever else they want to install in this house, well, now this 110 needs to be resized. Now, practical terms, we're in the real world. We land at 110. I'll tell you two realities that will happen. One, I'm going to think exactly how you think. And I'm just going to go up to the next size breaker because I'll let the homeowner know, hey, I'm going to go to the next size in case you want a future expansion. Maybe they say yes. Maybe they say, don't do any of it. Is it going to cost, how much more? $30 more from my overall price. You know, I think a 110 to a 125 is not a lot of money. So they'd be fine with it. Wires as well, but overall cost maybe $200-300 more for the whole job. They'll probably be fine with that. I would assume everybody would. So there's the first thing. The second reality is it's very hard to find a 110 main breaker system. All right, if you're trying to buy the combo panels, which is what every electrical company is trying to do for dwelling units these days, because they're all in one. It comes with the meter setup. It comes with the main breaker setup, and it has all of your little breakers below. And you can buy this whatever many spaces you need. But if you go to Home Depot, if you go to Lowe's, if you go into supply houses, it's very hard to find one of these at 110. All right, the most likely that you'll find is 125. So we're probably already in the real situation going to the next size breaker. And I ran into this. I was doing two houses. One of them, I did the load calculation like we did right now. I landed at 150. I went to go look for this meter combo, and I found 125 and 200, and that's it. And it was impossible to me and the homeowner online, Amazon, eBay, everything, could not buy one. So at the end, we just resubmitted the plans to the city for a new permit. Didn't take more than a couple of days. We just increased we can't decrease. I can't go to the 125 when I need 150. So I just made the main breaker 200. Increased the wire size a little bit. A homeowner paid for everything. It was fine.
As long as the homeowner paid for it, that's fine.
Exactly. So there's a lot of nuance to all of the things now when we deal with this as a question, the question is to say, what is the minimum size breaker? Minimum size breaker would be 110, and then all of that other stuff that I just went into. If it happens, good, but this is the question, so we're good. Now, if we were picking an overcurrent protection device, which we're not going to make it part of the assignment, but it will be a question in the exam. In the exam, I'll have a simple question. Like, I will give you a question like, I say a simple formulated question. I'll say, the dwelling unit has 26,290 VA. What size main breaker do I need? Or, what size conductor do I need? So we'll do both of them, so you'll know how to do that. So we just did the main breaker. All right, and I'll put it here as a reminder. 240.6 for the main breaker, and 110 is our. Now, for the conductor or wire, just to make it easy to write, we don't go to 31016, all right? And everybody does this when you first get one of these questions. You go to 31016, but that's where we always go size wires to, and we take this 110, and we do the 75, 60 degree column and all that, and we feel good because we remembered all of that, but we forgot the main thing, which is wrong article to begin with. Because I'm just running over to it right now, which is 31012. All right, and it's a table. It's an article. Again, all tables have the article that go with it, but ultimately we're looking for the table, which is going to be found on page, and I will mention it here in a second when I get there. Page 183. All right, on page 183, and you'll find this on page 183. Single phase dwelling service and feeders. And this is why we had to go to the panel first. Or sorry, we had to find our overcurrent protection device first. Because when you come to this table, you're not coming with the amperage that you calculated. You're coming with the main breaker that you chose. Now, we happen to, and it's really annoying that, and I wouldn't have planned it this way, that we happen to have both the same thing. It happens to be that the load that we calculated is also a main breaker, so that's annoying. But for example, let's say if this load was, 105 amps. Again, we're not going to 310/16 with 105 amps, 75-degree column finding, looking for that wire. We go and find the main breaker first. Again, that's why we did that process. And then we come here and we go, all right, main breaker that we chose was 110. The wire that we're going to choose is 3. All right, a number 3. So the correct size wire is a number 3. And I will show you what happens if you go to 310/16 with the 110 amps, meaning that you would go into the 75-degree column table. All right, just to point that out over here, if you went in there and you went looking for a wire that can cover 110, which would be the 115 here, you'll notice this wire is the number 2. So it's a larger conductor than the wire we're actually allowed to use, which is a number 3. Now, again, this doesn't seem like a lot. It really isn't by price of one to another. But if you got to do 100 homes and that contractor forgot 310/16 and they're pricing 100 houses with all number 2 and you're pricing it all with number 3s, your bid is just going to be cheaper. Again, does that matter? It matters for people who are doing this. But again, we're looking for right answers anyway. I don't like that I used the wrong color here. All right, so number 3 is the correct answer. 4, what is the minimum size conductor do we need? Would it be wrong if I bought a number 2 and put it in there? No, I can always go larger with my conductor size. The only thing that limits there is where this wire gets terminated to. I got to make sure whatever I'm terminating the wire to can handle a number 3, but as long as it can, or whatever larger wire I choose, a 1/0, whatever. If the terminal point can handle it, I can bring it. Go ahead.
The branch circuit wires are going to be made up of number 3 wire?
No. What are these wires? Are these my branch circuit wires?
Service phase wires.
Exactly. These are my service conductors or my feeders. These are my feeders coming into the main breaker of the house.
City.
From, panel to the connect to the city. I think the city uses aluminum, so theirs sometimes is a different size than ours. Because in aluminum, the wire would be slightly bigger, but because aluminum weighs less than copper, so the city always runs aluminum. Now, by the way, I've seen a lot of aluminum, especially here in, I don't know if it's a thing here, but all of the houses that I open up panels here that I, go do work on, every one of them has service conductors aluminum here in Tennessee. So sometimes it's like that, regional. Now, if we were choosing a number 3, you'll notice table has the aluminum. It's right next to it. So you can do that as well. You can pick these in aluminum, and you do get questions like that from exams where what size does this conductor in aluminum, and then okay, you can, now it's not the number 3, now it's a number 1 if I'm going aluminum. Aluminum's just a little bit bigger, but maybe around here in Tennessee, I don't know, I haven't built homes around here, maybe it's cheaper to get aluminum conductors here, so that's what they've gone with. But all right, I'm gonna pause here.